I'm Hotel Bravo 9 Golf Hotel Juliet. My name is Urs, Uniform Romeo Sierra, and I like to introduce you my Magic Loop antenna.
I built the magnetic loop because I need an antenna that is winterproof. A magnetic loop antenna is usually small and can be operated indoors. Since the magnetic loop antenna is directional, I also mounted it on a rotor so that I can rotate it. I have set up my magnetic loop antenna in the barn, which is located next to my vacation house. But what is so magical about my loop? Let's take a closer look. Basically, the Magic Loop is built like a normal magnetic loop antenna. It consists of an aluminium ring with a diameter about 1 meter and a capacitor to bring it into resonance. For coupling loop, I use the inductive coupling. I choose this coupling so that I can be QRV on multiple band without having to take adjustments. The coupling loop is not in direct contact with the aluminium ring. This results in even better SWR. The coupling loop is made from RG213 cable, which is short-circuited. Normal magnetic loop antennas still require a receiving antenna because the loop antenna is deaf if it's not tuned. My magnetic loop antenna does not need a receiving antenna because I have built ears in the antenna. How did I achieve that? When I rotate the band, the capacitor moves automatically. The magnetic loop is always in resonance. Therefore, I can do without a receiving antenna because my loop is always listening. To hear and transmit signals, the magnetic loop antenna must be tuned by rotating the capacitor. Normally, this is done manually or with a motor. Here, I installed the motor, which is coupled to the capacitor via an isolator. The capacitor is an air capacitor, which works up to about 100 of transceiver power. For the motor, I used a stepper motor that has no gearbox. This means that there is no need to consider gear backslash. The angle of the resolution is about 0.056 degrees. My self-made controller communicates with my Yaesu FT991 transceiver via the standardized CAT communication. Let's take a look at the controller box. Inside the controller box is a Raspberry Pi and my magnetic loop controller PCB. A screen, a keyboard and a mouse are connected to the controller box. With this you can control the magnetic loop antenna. It's also possible to control the antenna remotely via the internet. I designed the magnetic loop schematics and PCB with KiCad. The main computer is a Raspberry Pi. It communicates with a Raspberry Pico, which is used to control the motor. The onboard communication is done via an SPI bus. The motor driver is a DRV8825 chip. To To initialize the motor, I use a forked light barrier. The PCB was designed so that it fits onto the Raspberry Pi. When I first use the loop, I need to teach it. This is done automatically. In the first step, the position of the capacitor is initialized. This is clearly visible here. When the capacitor reaches the 0 position, the teaching routine begins. In the second step, the receiver is automatically switched to FM and set to 5 watt. And the FM carrier is then transmitted, and the measurement of the loop begins. In the third step, the SWR is measured at the lowest frequency of the band. The capacitor is then rotated until the SWR is minimal. Afterward, the frequency value and the capacitor positions are stored in a lookup table. Then, the next frequency is set and the frequency repeats until the entire band is measured. I also try to measure only the start and the end point of the frequency band and then interpolate the values mathematically. However, this is only worked to a limited extent. Here, you can see the lookup table for 80 meter and 40 meter. The most accurate results come when the entire frequency band is measured in adequate steps. When I rotate over the band, the antenna is always tuned. The capacitor always follows the frequency I set. A band change is also no problem. The antenna is always tuned to the maximum signal level, which is easy to hear. It is also possible to change the operation mode between USB, LSB, CW and data. It is also possible to automatically tune to any frequency locally. If the SWR is not perfect, you can also adjust the SWR manually. The GUI and main software is programmed in Python. The motor driver, which is on the Pico, is implemented in C. I programmed the user interface with Qt Designer. Since I operate the magnetic loop antenna with my FT991, I designed the GUI accordingly.
So, that was a brief description about my Magic Loop antenna. I hope you enjoy it and maybe I was able to inspire you to build one as well. I wish you 73 and best wishes from Hotel Bravo 9 Golf Hotel Juliet. Bye bye.